Here we're going to talk about a basic stoichiometry problem, and I've labeled a few different. I've labeled the chart that I make, and hopefully this simplifies it for you, so you can so you know what you're supposed to put where and how you can solve the stoichiometry problem. First, as you see right here, we put in right here what we have. What we have goes up in this box right here. We put it's likely going to be grams, so it might be like 15.5 grams of CO2 or something like this. We'll go through an exact problem in just a second, a particular problem. Then we're going to convert it to moles right here. On this part right here, we're going to convert to moles. There we do like we did in the previous ones, where we put we're coming from grams up here, so we're going to put the molar mass down here in grams, and then we're going to put 1 mole on top of the substance. Doesn't matter what one it is, we'll fill that in later. Over this next step here, we're going to put what we're coming from. This is our mole ratio, so the ratio of moles of what we're coming from to the ratio of moles of what we're going to up here. Then we're going to convert it to grams here, so we're going to put 1 mole down here of whatever we have. 1 mole of whatever, not what we have, but what we're going to. And then the molar mass of what we're going to is going to go up here on top. So let's get started with this one. We're going to look at this previous problem right here. It says the combustion of a sample of butane produced 8.5 grams of water. How much oxygen was used up? So we're starting with water, and we're going to oxygen in this case. So we know we have 8.5 grams of water. So let's put that in, because we see we have 8.5 grams of H2O. So we're going to put 8.5 grams of H2O. That's our starting point. That's what we have. Now, you see the next step is to convert to moles. So we have to look. Okay, we have 8.5 grams of H2O, but how many grams are in a mole? If we look it up, we have 2 H's and 1 O. H's are each 1. O is 16, so that's going to give us 18 grams of H2O equals 1 mole of H2O. This next step is where some people get confused, but it's actually quite an easy step. We know we're coming from H2O, so we're going to put H2O on the bottom here. We know we're going to oxygen, so we're going to put O2 on the top here. So what we're going to do is we're going to look and we're going to say, okay, what are those balancing numbers next to H2O and O2? Because that gives us our ratio. H2O, it has a 10 next to it. And we have 10 moles of H2O and 13 moles of O2. So that right there is our ratio. So we're going to put a 10 on the bottom, because that's what's next to H2O. So we're going to do 10 moles of H2O, and it was a 13 next to the O2, so 13 moles of O2. And what that shows us right here, this step, is just basically for every 10 moles of H2O that are produced or needed, or whatever that is that we have, there's 13 moles of O2 produced or needed, depending on which direction we're going. So that's a 10 to 13 ratio, and that'll help us get the right quantity in the end. Now we're going to take 1 mole, go on to the next step, and we know that 1 mole of O2, what we're coming from, is equal to, well, each O is 16 grams if you look up at its molar mass, so we're going to say 32 grams because we have 2 of them, because it's O2. 32 grams of O2. So what we did here is we started right there. We put the amount we knew, 8.5 grams of H2O. We got that from right here. Then we went and did the molar mass of H2O, put that on the bottom here, and 1 mole on top of H2O. Here we put what we knew, what we were coming from, which is H2O. We got it from the balancing number from this part right here. Up here we put our moles of O2. We got that from right here. And then we do 1 mole of O2 always on the bottom here, or 1 mole here of what we're coming from, of what we're going to, and we're going to O2. And then the molar mass on top. And the molar mass of O2 is 32. So that's it right there. So now we're done. We just have to take this times this times this times this divided by this times this times this. Now you got to make sure when you put it in the calculator, you have to put it in parentheses, or you have to do it separate. So you can times all the top together, times all the bottom together, divide the top by the bottom. If you try to put them all in at once, you have to make sure you use parentheses, so you put parentheses around all those on the bottom. So remember that. And once you do all that, you should get your answer. And if we plug this into the calculator, you should get about 19.6 grams. of O2. That means for every 8.5 grams of H2O that were produced, you should have had at least 19.6 grams of O2. And that is stoichiometry, a very basic stoichiometry problem. Now it does get different than this, but for now this is all we're going to work on, is these basic gram-to-gram stoichiometry problems, where we're coming from grams of one substance and ending in grams of another. So, if you have more questions, please let me know. I will try to post more videos on this, and we'll have some of the other topics involved in this section.